Hi, and welcome to another edition of As the Page Turns. That's right, we're moving on to section 4.3, multiplying polynomials. Again, I'm assuming, I hope it's a safe assumption, but I'm assuming that you're reading the book. You're not going to get everything out of just watching these videos, though I hope that they're very helpful. But you probably know you have your own work to do. In section 4.3, I'm simply going to be going over some of the examples that are present and explaining them as we go. We'll start on page 4.3-1 with example 1b, which asks us to multiply. We're going to multiply negative, and I'll put this in parentheses because it represents one term. It's negative 5x squared y times 4x y cubed. And if we think about this, everything is being multiplied here. We have the negative 5 being multiplied to the x squared, which is being multiplied to the y, which is being multiplied then to the 4, and times the x, and times the y cubed. You don't need to write all these out. This is, though, what's actually happening. One thing I am going to do is try to get all of the different pieces together. I'll get all the constants together. And the reason we're able to switch some of these pieces, these factors around, is because of the associative property and the commutative property. So I'm going to have the 5 and the 4. I'll write them together. They're the numbers. I'll write the x squared times the x together and the y times the y cubed. So it'll look like this. Negative 5 times the 4 times x squared times x times y cubed. No addition anywhere, all multiplication. And some of this is very simple. Negative 5 times 4 is a negative 20. X squared times x. I want to remind you that we don't see the variable, or excuse me, we don't see the exponent, but there's an exponent of 1 right above the x. And so if we're going about the addition of exponents, that product rule that we saw in the beginning of chapter 4, that will make it x to the 2 plus 1, or x to the third power. Similarly, y has an exponent of 1, and combining those two together, it's y to the fourth. Y to the fourth. And, you know, this could have been done in just one step. If you think about, we're not doing any kind of distribution, we're just, everything, like I said, is multiplied. So it's negative 5 times 4, negative 20. Whoops. Negative 20. And then x squared times x is x cubed. And then y times y cubed is y to the fourth. So it could be done in just one step. But here's, you know, all the individual steps all the way throughout. So the explanation is there. All right? Anyways, that's section 4.3, page 1, example 1b. Let's erase all of that and go on to the next page, page 4.3-2, example 2b. And this says that we have a quantity, a single term, negative 5 x squared y, quantity squared. What happens when we're squaring a monomial, when we multiply a monomial times itself? And, well, multiplying it by itself really is the way to go about this. That's negative 5 x squared y times, I'm going to put this negative 5 in parentheses so that it doesn't look like we're subtracting anything, because we're not. It's all multiplication in x squared y. And just as we saw before, we're going to multiply, you know, the numbers together. Negative 5 times negative 5 is positive 25. And we'll multiply the x's together, x squared times x squared. And we're going to add those exponents together. It's x to the 2 plus 2, which is x to the 4. And that's what we get here. 25 x to the fourth. And then just y times y is y squared. And there you have it. Now, you might also have remembered, by the way, I'll rewrite the problem here. Negative 5 x squared y quantity squared. How when we have powers to powers, when we have everything being multiplied here, how we can distribute that power as a power. If everything is being multiplied, we can distribute it as a power, and that means we would get negative 5 being squared, and x squared being squared, and y being squared. And negative 5 being squared is that positive 25 that we saw in the other answer. X squared squared, you might recall that we multiply the exponents. I know that some of these exponent rules are a little bit challenging, but this becomes x to the 4th power. And then y times y is y squared. Same answer, just an alternative method for squaring a monomial. All right? So let's go on to our next example. Example 3 on page 3. So page 4.3-3, example 3. We'll do example 3b, which says this: negative 5x squared times the quantity x squared plus 4x plus 1. Did I do that right? Oops, that should be minus 1, excuse me. Okay, there, now it's minus 1. And what we're going to do here is distribute. When we distribute, we're going to multiply negative 5x squared times each of these terms inside. And if you think about it, it's like multiplying a monomial, negative 5x squared, times this single term, that monomial, x squared, and then coming back and multiplying the negative 5x squared again times the positive 4x term, and then coming back to the negative 5x squared again and multiplying it by the negative 1. So that's how it's going to be when we distribute. Now, I will show every step here. You might eventually, when you get better at this, and maybe even right away, I don't know, you might be able to just do it all in one step. But I'm going to show it out completely. This is going to be a negative 5x squared times x squared plus. Then negative 5x squared, let me put that in parentheses. I'll do it each time like that. Times the 4x that's there. Minus negative 5x squared times the 1. Now the most unusual piece in all this actually is that minus sign right there. I wrote it as a minus, and then I said it's negative 5x squared times 1. Well, if I didn't write all these out, I might instead have said this: negative 5x squared times negative 1, and just done it all in one step. And we'll conclude this problem by actually doing it from the beginning all in one step, though. But as it is, here's what we get. Whoops. Negative 5 x squared times x squared is x to the 4th power. We could think of just adding 2 and 2 to make 4 in that case. Now, I could write plus. In fact, I will on this one case. And then when we go back, we'll see an extra step is needed here. Negative 5x squared times a positive 4x. So negative 5 times positive 4 is negative 20. And then x squared times x, x cubed. So that's a negative 20 x cubed. Because I don't like to see a plus sign and a minus sign right next to each other, I'll put that in parentheses. And minus. And now, simply, negative 5x squared times 1 is negative 5x squared. Let's see, negative 5x to the 4th is fine as it is. Now, plus a negative, we usually write that simply as minus. And this is the simpler way to write it, is say minus 20x cubed. So I'll write it that way, minus 20x cubed. And minus a negative 5x squared. Minus a negative. That's a double negative. Minus a negative, if we change that to add the opposite, they become plus a positive 5x squared, or simply plus 5x squared. And I believe that we're finished. We have it simplified. But let me show you this problem again from the beginning. I'm going to multiply negative 5x squared through to the trinomial x squared plus 4x minus 1. And my speaking and thinking are going to be a little bit different. Instead of writing out, that negative 5x squared multiplied by each and every one of them, instead I'm going to think of negative 5x squared times positive 1x squared, and just think of it as monomial times monomial. That would give us a negative 5x to the fourth. Then, think, before we write anything down, come back out here, negative 5x squared times a positive 4x. We should treat that plus sign as a positive 4x. So negative 5 times positive 4, negative 20. X squared times x is x cubed. The way I'm going to write negative 20x cubed, though, is a minus 20x cubed. That means the same thing. Negative 20x cubed and minus 20x cubed. Lastly, negative 5x squared times negative 1. A negative times a negative is positive. So that'll end up being plus just 5x squared. And is that the same answer we got there? Negative 5x to the fourth minus 20x cubed plus 5x squared. Yes, it is. And we're done. And the problem is already written also in descending order. Descending order, x to the fourth, then the x cubed, and then the x squared. Okay? That's example 3b. Now, after example 3, after page 3, there's this thing called page 4. Yeah, I know. And you know what? There's like page 4s after all of the page 3s. It's kind of amazing. But in this particular one, there's an explanation that I'm not going to go over right now. And I'd really like you to read it. Especially because I think it's kind of clever, But it kind of helps us set up the next example of multiplying, a binomial, 2 terms, by a trinomial, 3 terms. And this explanation on page 4 of section 4.3, clever as it is, I think it's going to be helpful, too, to your understanding of how it is that we can multiply these together. So let me erase all this, and we're now going to be skipping on to page 5.